right, so I hear you guys discussing answers. Have we settled on one that we agree with here? Anybody in your group or any groups have a common solution to this problem? Not many? Okay. Well, I figured it might be a little challenging at first just because this was what we left off with the other day, and it was kind of at the end of the class. Remember our percent equation. I didn't say you had to use the percent equation on this. You could use anything you want. You could use a proportion for all I care. But the percent equation from the other day, remember we take the part and we set that equal to the percent, capitalize it for a reason here, times the whole amount. All right, now tell me something about the percent in this equation. What do we know about the percent in this equation? A rule? Well, I'm not even this specific problem, a rule, but just like in general. In that percent equation, well, okay, let's go back to this percent. What form is it in when you put it into this equation? What form do you need to insert there? Frankie, the decimal form of it. Okay, so if you're using the percent equation, don't forget that part of it. Like if it was 50%, you wouldn't put 50 in here. You'd put 0.5 in there. Okay? And we talked about how taxes just represent an additional amount paid and the funding goes elsewhere. So we're talking after the tax, you paid $52 for this video game. So that's what you paid out the door, $52. But there was a 6.5% sales tax that was added to that, to the original amount to get you to the $52. We want to know what was the original cost of the game. Okay? So first question, very basic. Is the original cost going to be more or less? Less, right, because this is the taxed amount. This is the amount that you paid. So if you set this up using the equation, and I'm going to do this with the equation with you guys, and we can look at the proportion also. That $52, would that be considered the part or the whole amount? That might have been the first hurdle that we had to get over. Like we weren't sure where to put that. Max, how many would have put it in the whole amount spot? Would any of you put it in the part? Okay. This is the tricky part of interpreting this. Think about when you solve these tax problems, the whole amount is considered the original amount. Okay? So like the original amount that we paid is unknown in this case. So in this particular equation where we have the whole amount here, that's going to be your variable, your unknown. The part is actually the final price, believe it or not. Because when you pay tax, what can you tell me about the percentage that you paid? When you pay tax on an item, in general, what's that mean about the percentage? Kate? Good, you're paying over 100%. Okay, so in this case, the part will be larger than the whole amount because of that fact there. So part here is the unknown. So if I just want to write, or I'm sorry, part in this case, I said it backwards, is the 52. I know the percent, and I know, or I don't know rather, the whole amount. I'll put a W there. But the percent, what are we going to put in for the percent here? Remember, we just talked about how it's the decimal version. But 52 is some percent of the whole amount. What do you think, Aiden? 1.065. Explain that to us, Aiden. Why is it that? Yeah, so you got a 6%, 6.5% sales tax plus the 100% that you would pay. If you don't pay a tax at all, you're still paying 100% for the item. It's just you don't have anything extra. Well, the tax is extra. So it's 100% plus this 6.5%. So really we're paying 106.5%, which Aiden converted into its decimal form, 1.065. Okay? And this is where we kind of struggled on Friday. Felt like a Friday because we had a break. Tuesday, sorry. how do we get W isolated here? What's the one step in our equation that we have to do to get W alone? This is where some of us got to this point, and then it was like we stopped. We're like, oh, I forget. Brooke, what do we do? Yeah, 52 divided by 1.065. And what's that give us? I don't even, what do you have, Brooke? 48.82, that's rounded to the nearest cent. Yeah, you guys agree? So the video game on the shelves was advertised to cost $48.82, but when you left, you had paid $52 for that. Nadia's in 7th grade and already has an issue with taxes. It's only going to get worse as you get older. All right, let's go through, check our homework here. Okay, so we're going to look at our homework answers. You guys are going to do a quick check. I'll go over any of these with you. Starting at number 12. So we can see 12, 16 through 18, and 23 right now. Remember, the expectation was that we were going to use the percent equation here. So make sure you're able to do that. When I did walk around, I saw some of us using the percent proportion, and I know you're comfortable with that, but I still need you to be able to use the percent equation when asked, even though that might not be your preferred way. So like on number 12, for instance, going back to that original part is equal to the percent times the whole amount. 54 is what percent of 60? Tell me how I would put this into the percent equation. I'm only going to do this with the first or one or two, just spend a little time here. Ava? $54 is the part, 60 is the whole amount. You get the percent. Now, when you solve this, you're going to divide both sides by 60. But the problem on this one, not the problem, but the reality is that when you get your answer, you're going to get that right there. So then what do you have to do, Ava? Multiply by 100. Why do we multiply this by 100? Exactly, right? This is set up to be the decimal form. So when you solve for the capital P, you know it's in the decimal form. You always have to take that extra step, convert it to percent form, which means multiplying it by 100, right? But that's the formula there. That's the percent equation in use. Let's go. Lots of lag, yeah. All right, let me skip this ahead. What was the next one, 28? All right, I guess I gotta go. Oh, the dreaded red button. No worries, I can fix this. All right. So 28, the correct answer is 529. I give you 29? Yeah, 29 should have been 96. So the question says 2x, the quantity, is 4% of what number? It says use the percent equation to solve if each problem has a value of x equals 10. Well, I don't know how many of you did this, but I would recommend this. This number here, this expression 2x, is the part, because it says this is 4% of what number, the whole amount. well, I assume most of us just substitute a 20 in here, right? 2x is 20. So 20 is 4% of what number? Just solve for x, right? It looks more algebraic and challenging at first, but when you make that simple change, when x is 10, this just becomes 20. And then you're going to go 20 is 4% of some number. And solve it, you'll get 500. Same thing on the next one. Find 40% of 240. Okay, so you're going to do 0.4 times 240 if you do the percent equation. Number 33. Does taking a 10% discount on an item, then adding a 10% sales tax, result in the original price of the item? So you have an item that costs so much money, you take a 10% discount, and then you tax it 10%. Does it bring you right back to where you began? Cameron? No, it doesn't, right? Why not, Cameron? Can you just...
Like, for example, I used one that it was originally $100.
So she was smart and she used nice numbers to work with. So it's $100, okay? Go ahead.
So if you take 10% off, it costs $90.
Right, so if I take away 10%, that's going to give me $90, okay?
But then you have to take 10% of 90 and add it on, so it's 99.
Yeah, so 90 times 10% would be $9. So then with the 10% tax, it's only going to bring it back to $90, okay? So in general, why does that not work? Like I could substitute any number and be like, oh, 20% discount, 20% tax, or whatever. Why does it not work? Jack? Of a different number. Absolutely. Yep, exactly. You're taking 10% of two different numbers. And that's not going to result in the same outcome. So that's why, in this case, it does not work. All right. What was our next one we did? 34. Oh, we did 34, yeah. Right, two different expressions to find the total cost of an item with a price of $y if the sales tax is 8%. Did any of you do the percent equation and then the percent proportion? Okay, well, I was just trying to think of logical ways to handle this. You might have just gone with the two methods we've discussed so far. So let's go with, give me one. Give me one that you used. Jack?
8% y plus y.
So 8%, like, did you write it as a decimal?
No, I wrote 8%.
So 8% times y
Plus y.
plus y. So then I could change that. I would put that into a decimal, like 0.08 y plus y, right? They find the cost of an item with the price of y. Yeah, that would work. Because what you're going to do is you're going to end up taking, because this is 1y, you're going to end up taking 1.08 times that amount, right? You're taking 108% of that number. Bless you. So that would work. Anything else? Go ahead, Nani. Do you want me to use y because they said y here? Well, I'm saying, you gonna tell me y is another part of this equation, or do you? Yeah. So you want to use y? Just tell me what you had. We'll figure it out. Y divided by 1.8. So y would be the whole amount, right? Because that's what it costs, okay? If this was the part, if y was the part, then that would work. But y is the whole amount, so that wouldn't work. We would have to end up multiplying by 1.08y. So that's what I was thinking on that one. Okay, the other thing, guys, I was thinking was a percent proportion. Okay, so part to whole. Part, I don't know what the part is. I know the whole amount is y, right? And then that's 108 to 100. Would that work? Like if I had it, like let's say it's an x. Okay, to find x, I would take 108% of y. You can do something like that. All right, and then 45. 45, the answer there, since this was a review, I'll just quickly go through. Should have been 26.4. You're just converting. And what was the other? 50? Writing these with exponents. Number 50, a couple ways you could have done it. You're going to combine what you can. Like 4 times 25, I would write as 100. So 100 times a to the 4th times b squared. Okay? That's what I would do. Because you have 4 a's, 2 b's. You're all being multiplied. So 100 times a to the 4th b squared. Some of you might have put like 4 times 25 times a to the 4th times b squared. That's fine too. All right, let's finish out. Let's get our notes out here. We got a lot to cover today. Since we missed the day yesterday, I had originally planned to do something with an activity. I'm going to skip that today. We're going to jump back into our notes and just kind of work our way through it. Take a look in Chapter 6, Section 3. We did not get to example 6, I believe. Is that correct? We didn't do it? Okay. Well, let's do this. Let's do example 6 on here. It's another tax problem. I think we could use the extra practice with this. But it's saying a $45 mixer sold for $47.70. What's the percent of sales tax? So this is a good review. This just kind of covers what we've been talking about. We want to know the percentage that was applied to a $45 mixer to raise its price to a $47.70. And it says you can use the proportion or the equation, so whichever one you're more comfortable with at this point, go ahead and use it. Yeah, because that, like what you, since the part was greater than the whole, you're going to get a percent over 100, but then you have to remove the 100 that you would have paid normally. Yeah, so you subtracted, is what you did. Good. Okay. So just looking at the different ways to do it here. I've seen a mixture. Some of you use the equation. Some of you, I think most of you were using the proportion. Just informally when I checked there. For those of you, the most common way that I was seeing was we were taking the price with the tax over the original price, percent to 100. Okay, several of you saw that or did that, something like that, and that's absolutely fine. Okay, but when you get an answer here, there's something you have to do with it in order for you to answer this specific question right there. So without me giving you numbers here, tell me, what do you have to do with the answer, the value of X here, to find the percent of sales tax? What is it, Jack? subtract 100 from that, right? Because what do you get for the value here? I think you have them backwards. I think you must have used 45 as the part. Yeah, you want to reverse it because the part, believe it or not, includes the tax. Okay, and that's the way we want to do this. The whole amount would be on the price tag, right? How much it costs without the tax. I know it's kind of odd to visualize it that way, but that's the way it's going to be. Go ahead, Ava. You get 106, right? So 4770 is 106% of the $45. So your taxed amount is 106% of the original amount, which means that you've actually paid the difference between that and 100. You've paid 6% extra as a sales tax. Okay? Now, if you didn't want to do it this way, if you just wanted to do it and solve it so that you get 6 without having to subtract, can you think of a way that you could have done that? You got a way, Frankie? Did you subtract the 2 to start? Yeah. So what's that difference, Frankie? Yeah, so he found out that he paid $2.70 in sales tax. Out of, did you use 45, Frankie? Okay. And when you solve this, what do you get for x? You get your 6% right there. Okay? So the difference here is that this was your original plus the taxed amount, whereas this was just the tax. So that's why this answer gives you the direct answer. On this 106% number, you have to remove the original 100% from that. You just have to know when to do it, when not to do it. So hopefully that kind of alerts you to when you would and when you wouldn't use that. All right. We're going to hold off on that closure table right now. We're going to maybe do that tomorrow. So just skip that part. Let's go to the next section. I want to begin this percent of change section today. Something that I think you guys are going to pick up pretty quickly. In fact, I'm going to expect that you'll pick it up pretty quickly. So I want you to try this first problem here. It says in 2016, Pittsburgh's population was measured to be 303,625. The largest recorded population of Pittsburgh occurred in 1950 with a reported total of 676,806 people, according to the United States Census. We want to know the population, calculate the population difference between these 2 years as a percentage. Okay, you'll hear people talk and report about, oh, it was this many percent increase or this many percent decrease. That's what we're talking about here. So obviously from 1950 to 2016, the population in Pittsburgh has declined. It went from almost 700,000 to a little over 300,000. That's a pretty big drop. But we want to figure out what percent did it drop. Okay? So go ahead and try that without me assisting you. Just you guys can discuss together and see if you can come up with a number here. How many of you have figured out our percent decrease? Guys, a lot of talking. Not many people have figured it out, though. All right, let's go with this. I want to know, just give me your final percentage. It's obviously a percentage decrease. So if somebody was, summarizing the population trend in Pittsburgh, you could say, well, over the course of these, 66 years, the population has decreased. What percent would they have said? What would they say it has decreased? Cameron, what'd you say? Yeah, about 55.1% decrease. How many of you successfully got that answer there? Okay. All right, let's talk about it. Cameron, can you describe what you guys talked about or what you used to do this?
Okay, so what we did first was 676,806 minus 303,625.
Okay.
And we got 376,181.
And that number there represents what?
How like the difference between the two.
Yeah, the difference between the two populations, right? How many people less there are in Pittsburgh than there were 66 years ago? Go ahead.
Then we did proportions.
Mhm.
We put 373,181 over 676,806, and we did equals to
Mm-hmm. And then when you got 55.1, you said? Okay. And that would be, I'll put an arrow down, for a decrease, of course. All right. Did anyone get that same number but do it differently? Because there are many ways that you could achieve the same result. Kate, do you have a different way? Yep. Equals 676, 806 over 100. Yeah, and for those of you that are looking at, you could have done this over that equals y over 100, same thing. So what do you get for y, Kate? 44 point, I'll call it 9 if we rounded the tenths, and that's a percent.
And then I did 100 minus 44.9.
Good. Now, why did you do 100 minus 44.9? I agree with everything you've done here. Absolutely. So the population in 2016 is 44.9% of what it was in 1950. So that means that we must have lost the 55.1%. So if you recognize that, some of you might have got this answer and been like, oh, it's a 44.9% decrease. That doesn't mean that. It means that the new population is 44.9% of what it was 66 years ago. So we have to be able to interpret the numbers as they come out to us to get that number there. Anybody do it differently and still get the same answer? And I'm not talking like, oh, I used an equation to do it, but just set it up completely different. All right, I think those are probably the two most popular ways I would say to get that. You just have to know when to subtract, okay? So that brings up this concept of percent of change. Like, what is percent of change? Let me give you the definition that I want you to write. Percent of change is a ratio comparing the amount of change to the original amount. So when we say something has been like a 40% decrease, okay, you're comparing what it is now, or the amount that has changed to what it is now, right? So, or to the original, I'm sorry. So like, look at this first example here, this proportion that Cameron gave us. This kind of emphasizes this concept exactly, where it says comparing the amount of change. The population changed 373,000 over those 66 years. It was originally 676,000. When we say originally, think chronologically. What came before? That would be the original amount. Because I always get this question. It's always like, well, would you consider the new population the original amount or the 1950 population? Chronologically, we would go with 1950 because that's how we're measuring it. That's what we're measuring it against. Okay. Now, if you talk about, I'm trying to think of an example where we would use. So let's say somebody can lift 50 pounds today, but in 2 months they can lift 51 pounds. Really made a lot of progress. Okay. So again, that's chronological. You'd say, all right, well, the change is one pound compared to the original 50 pounds because it came prior to that amount. All right? So the formula that I want us to use here, let's go down just a little bit further. That diagram there, which we're not going to spend much time on, that diagram there just kind of emphasizes how businesses could apply this information. But if we're looking to use a proportion, which I think most of us will here, yeah, the delay is, it's like watching TV, you know, and you hear the words, but the mouth isn't moving yet, you know? Okay. So I'm going to write this as a proportion. The parts that we're going to compare represents how much has something changed. In this case, we're talking population. So how much has it changed? And that's what the way Cameron did it. She found out the difference between the two over the original. And the original amount. And then that would just be equal to the percent to 100, of course. And if you wanted to write this as an equation, you certainly could. You would just say the amount of change equals the percent times the original amount. And that would be your way of doing it that way. But Kate showed us that you don't have to do it this way. You just then have to remember to take away the original 100%. So for instance, the way she did it, she compared the new amount to the original amount and then got a percentage and then just had to subtract 100 from that. And that's absolutely fine. Okay? So the diagram below, just an example. Businesses use this all the time, year to year. Okay, well, how much did sales increase or decrease? Okay, well, you can look at it graphically here, and you can see, like, for instance, they're talking about the average growth of global car rental sales from 2010 to 2018. So if you look at the first data here in 2010, since it's above the 0% line, that shows that it had a 0.3% increase. Not much, but still an increase. The second year, 3.7%. So comparatively, that's pretty drastic. You think, oh, wow, that's way more growth. But then as you start to scan a little bit farther here, not that far. Where are you? Come back to me. I know you guys love watching me struggle with this thing. There we go. All right. So then the third year, you can see it dropped 5.2% from the previous year. Okay? It's measured against the previous year. So this had a 3.7% increase. This had a 5.2% decrease. But if I asked you to compare, for instance, this year to this year, the data is going to be a little different. Okay? They're going year to year. Like this negative 3.1%. All right? I assume this actually might be measured to the original. I'm sorry, I said that wrong. So like from the original, it was a 3.1% decrease, and so on, okay? So then you get a big snapshot of how the industry has changed, grown, decreased, whatever, from looking at that. Speaking of industry, flip it over. We're going to do this next example here. Try to get this one in before we wrap up. The Super Bowl advertisements, which many of you might watch the Super Bowl strictly for the advertisements. The quality of the game this year wasn't that great, so hopefully you enjoyed the commercials. And where are you? Its cooperation level is at an all-time low today. Where are you? Come on, come on, come on, come on. Oh. All right. You could be like, what percent of the day did Mr. Luck spend messing with his, well, probably a large percentage of my day. All right, you guys have the formula. You can apply that to do tonight. We'll talk more tomorrow. See you guys. All right, so let's finish out these last two examples here quickly, relative to this percent of change concept. We talked about the Super Bowl there for a second, but the advertising money that gets put into the Super Bowl is just astronomical. You can see first year of the Super Bowl back in 1967, the 30-second commercial. Typically, that's how they measure these commercials in 30-second spots. So a 30-second commercial was only $42,000. Now back then, of course, $42,000 was an extreme amount of money. Well, jump ahead to 2012, you can see that the average cost for a 30-second Super Bowl advertisement now costs $3.5 million. So to get your product on TV during the Super Bowl was going to cost you $3.5 million for 30 seconds. And that number continues to rise every year. In fact, jumping ahead a few years to 2019, this year, the Super Bowl ad, 30 seconds again, went up to $5.25 million. Okay? So, we wanted to talk about a percentage that this is increased over the years. Of course it's increased. So the first part of this says, calculate the percent of change from 1967 to 2012. So from the very first Super Bowl to 45 years later in 2012, well, we're going to look at the difference and how much has it changed over those 42 years. The original amount in this case is your 42,000, but the difference here, you have 3.5 million, which is 3,500,000. So find the difference between 3,500,000 and 42,000. And that would get your amount of change. Like, how much has it changed? Well, if you do that calculation, you would see that the price has increased $3,458,000 per 30 seconds. The original amount, like I said, is the starting point. Chronologically speaking, it's from 1967, which is $42,000. And we want to set that up as a percent proportion, or if we set it up like that, you would get this amount right here. And go ahead and solve that out, see what you get. Okay, checking it out, you'll see that it was an amazing, and this is not a typo, 8,233.3 repeating, I'll write it as 1/3%. Clearly that's an increase. So 8,233.3% increase from 1967 to 2012. All right, well, let's look at another value here from 1967 to 2019. So seeing that it grew even more, we want to find the difference between the two and factor it in this way. Or you could just compare the 5.25 million to the 42,000. You could do it that way. But then remember, at the end, you're going to have to remove your 100%. I figure it's probably easier to do it this way. I'm going to do this one as a percent equation, just to show you both sides of this. So the difference between the two amounts from 2019 to 1967, or vice versa, was $5,208,000 per 30 seconds. That's the part. The percent, we don't know. The whole amount, again, is the original, the 42,000. All right, so if you solve this equation, you're going to get a value for P that's equivalent to 124. And that does not, of course, mean that it's a 124% increase. This is the decimal version of the percent. We have to convert this into the percent form, by adding 2 zeros, which means this was a 12,400% increase in cost for the Super Bowl. All right. All right, why don't you guys try number 3 quickly on your own. Talking about how height has changed over some years. So figure that out. I'm gonna just pause the video now while you work it out individually, and then we're going to go through it together.